So we hear about pH in many different biological systems and many other chemical applications. What this means is that the pH, which actually corresponds to the relative ratio of hydronium ion, or H plus ion, to hydroxide ion, is a very important characteristic of solutions as well as biological systems. And oftentimes it's very important to maintain that ratio of hydrogen ion to hydroxide ion, or in other words, to maintain a pH level. The method we use, or the method that's used to maintain pH, is something called a buffer. So there's two key things to buffers. One is that buffers are going to stabilize the pH, right? So it's going to help maintain that ratio of hydrogen ion to hydroxide ion. And the way that we do that is that a buffer is going to contain two components, a weak acid and a salt of its conjugate base. So here we have a depiction of this. So our weak acid might be something like acetic acid, so HC2H3O2. Right? So that's acetic acid. Now, the conjugate base, the salt of its conjugate base, well, what we really need is the conjugate base of acetic acid is the acetate ion, C2H3O2 with a minus. So that's the conjugate base of acetic acid. What they mean by a salt is that we have to have a cation to go along with that anion. That would be together there. Now, that's going to end up being kind of a spectator here. It's not going to be very important. The significant parts are the weak acid and the conjugate base that we want to have present. And so we combine both of those things into the solution down here at the bottom. And what we're going to do now is take a look at what happens to those when we add an acid or a base to this mixture. How does that help maintain a constant ratio of hydrogen and hydroxide ion? All right, so first of all, buffering when we've added an acid to solution. So over here on the left, they have hydrochloric acid that's being added to solution. So it's HCl over here. And of course, when you put that into water, HCl is a strong acid, so it's going to come apart 100% into H plus Cl minus. And again, the Cl minus isn't really going to do too much here, but that H plus that gets put into solution is going to significantly alter the pH. So what we want to do is try to avoid having that alter the pH. So we're going to neutralize that H plus. Now here in the picture, they've shown the HCl together. Really when you put this into water, it's pretty much just going to be the hydronium ion or the H plus. And so what we're going to do then is that H plus is going to react with that conjugate base that we have present in solution, that part of the buffer. So in the example we had before, the acetate ion. And so those two are going to combine and form the weak conjugate acid. Now, again, what this does is, because it's a weak conjugate acid, it's going to stay in that HA form. It's not going to dissociate into or ionize into the H plus and the A minus. So it'll stay that way. In essence, then what we do is we maintain that H plus concentration that we had before the HCl was added. Again, by using the conjugate base to react with that H plus that was added to solution. And again, the chloride ion is just a spectator ion, so that's just kind of hanging around there. Now, if we look at buffer neutralizing a base, so now we're adding something like sodium hydroxide, for instance. And of course, sodium hydroxide will dissolve completely in water. And so you end up with sodium ions and hydroxide ions, as you can see in the little box there. And again, here, this is going to bump up that OH minus concentration. And to maintain the pH, we can't have that happen. That's going to significantly change the pH. So what we want to do is reduce that OH minus ion that we've added to solution. So we're going to make use of the weak acid to do that. So that weak acid will react with that OH minus and form water, right? So the hydrogen of the acid is going to break off and combine with the OH minus, basically neutralizing that. And we end up, of course, with more of the conjugate base, the A minus, but that won't significantly change the pH. The OH minus that's added directly will have a significant effect on the pH. So if we neutralize that, we can try to maintain that pH and try to keep it from changing drastically. Buffers, again, they don't completely prevent the pH from changing, but what they do is they minimize that change pretty significantly over if they weren't present. So just a brief recap, buffers are going to help maintain the pH by utilizing a weak acid to neutralize any base or hydroxide ion that's added to the mixture. And the conjugate base will be added to neutralize any acid or H plus that will be added to the solution.